These are the solutions for problems 7 through 15 on the study guide for chapter 2. So let's take a look at number 7. So here we're going to graph this equation. So when I graph the equation, I'm going to pick some x values, and I'm going to come up with some y values. Now I like to have a chart in which I write the rule down, which is negative 4x plus 5. It just helps me as I come up with my outputs when I substitute my inputs in there. And I'm just going to pick 3 points for right now, negative 1, 0, and 1. This just gives me 3 points, so I get a nice looking line, and they're not very big points. Some are negative, some are positive, and 0 is always a good one to use as well. So negative 1 in for x. And so I'm multiplying negative 1 times negative 4, and I get a positive 4. And then I have to add 5, and that gives me 9. And then I plug in 0 in for x, and I end up with 0. And plus 5 gives me 5. And then 1 in for x, I get negative 4. And then plus 5 gives me positive 1. So now I'm going to plot these points. So x is negative 1, y is 9. Now, on this graph, it doesn't look like I'm going to be able to make it up 9 spaces. So I'm going to have to not use this one and go to the next one. 0, 5. Over 0, up 1, 2, 3, 4, 5. That would be my point. And then 1, comma 1. So over 1 space, up 1 space. Now, since I only have 2 points, I could just draw the line and be done with it. But since I wasn't able to fit this one, I'm going to try one more point. I'm going to try 2. And I'll go ahead and plug that in. It makes negative 8 plus 5 gives me negative 3. Just to make sure I've got it on the right line. So I'm going over 2 spaces and then down 1, 2, 3. And yeah, it looks like that makes a line, so I can go ahead and draw that line between those points. And so draw some arrows at the end to show it goes on forever in both directions. Well, let's take a look at the next one. And again, you can, before we move on, let's take a look at the this line one more time, and I want you to verify that we have those points correctly, or correctly labeled. And so if you look at it, the y-intercept is 5. That matches what we said it would be the y-intercept here, and the slope is negative 4 to 1. Notice how if I go down 4 spaces and over 1, I end up on that line. Try it one more time just to verify. Down 4 spaces, over 1, yes, I am on that line, so that is correct. Let's take a look at the next one. I'll do the same sort of things I had done before. I'm going to take some x values, plug them into the rule, and find out what the outputs are. Now I'm going to again try the negative 1, 0, and 1. So I go ahead and substitute. And so negative 1 in for x, so I have a negative 1 plus 1 gives me 0. 0 in for x, 0 plus 1 gives me 1. And 1 in for x, I have 1 plus 1 gives me 2. So I go ahead and plot those points. 1 to the left, up 0. And then I have over 0, up 1 space. Over 2, or 1 space, up 2 spaces. And I can see that, yeah, that's a 1-to-1 graph. It's increasing. It's an increasing line. It crosses at 1, which is what we said. And the slope is 1-to-1. And that's the number we have in front of x as well, so that would be correct. And look at the next one. I've got x. I've got my rule, 2x minus 3. And then I'll have my outputs, y. And I go ahead and substitute these same numbers, negative 1, 0, 1. Putting them in for x, I've got 2 times negative 1 gives me negative 2, take away 3. Now remember, same sign, so you have to end up adding, makes negative 5. 0 in for x, you end up with 0 minus 3 makes negative 3. 1 in for x, you got 2, 2 minus 3 gives me negative 1. And you can check your outputs, see how there should be a pattern. If these are going up by 1, these should have a pattern as well, and they're going up by 2. So let's go ahead and plot those points. Negative 1 down 5 spaces, so 1, 2, 3, 4, 5. And then we go over 0 down 3, 1, 2, 3. And then over 1 down 1 space. So we'll draw the line between those points, and you can just verify and make sure that you indeed do have the correct line by checking the y-intercept. So the y-intercept is negative 3, that matches. The slope is 2 to 1. Up 2 spaces over 1 gets me to the line. Up 2 over 1 gets me to the line, so I know I've done it correctly. The next question asks us to write a statement that best tells the story of the graph. Well, looking at this one is speed, and this axis is time. So I would say something to the effect of a person has a constant rate of speed, or starts at a constant rate. So we'll just say a person starts at a constant rate of speed. So they just are starting. They had already been going. They had been in a stop position. They were already going when this chart was made. And so they're going at a constant rate of speed. That means we have the flat line. So we've talked about that now. Now it's decreasing. So when I decrease all the way to the bottom, that means I slowed down and stopped. So that's what we need to state next. So a person starts at a constant rate of speed, then begins to slow down to a stop. So now we've covered up to this point. Then immediately they begin traveling again. Then they begin to go. So that means they're going here, they're accelerating. They begin to go, but at a slower. Actually, let's mention something about how they end up getting up to a speed, but it's at a slower rate. So they begin to go, but begin traveling at a constant rate at a slower speed. So let's mention that. But acquire a constant speed at a slower rate. So they do acquire that constant speed. They get up to a speed, but it's at a rate that is less than where they were before, maybe almost half that. So we've covered all the bases of what we were talking about. Now the next one, same sort of thing. I come up with a story that best tells the graph. So it looks like this is gallons of milk, and this is time. So it looks like at this point we've got an empty container. So a empty container fills with milk at a constant rate. So it's a constant rate because it's going up at a sloped angle. And then it reaches this capacity. So we'll say an empty container fills with milk at a constant rate to a capacity and stays at that amount for a short period of time. So they stay there for a short period of time. So we've covered this part right here. So they stay at that same capacity, that same amount for a short period of time, and then the tank looks like it begins to empty, or the container. So then the container begins to empty, and it begins to empty until it is totally empty. So that kind of covers the basis. So we showed how it's decreasing line. It means that the milk is starting to empty, and eventually it will. So that is number 11. Let's take a look at number 12. This asks us to write a rule for the algebraic expression. So what we want to do is we want to look for either a common difference or common ratio. So right away, when I look for the common difference, I see 20. When I look at common differences, I'm doing y minus x. And I see 20 minus 2 equals 18 when I subtract these two numbers. And then 40 minus 4, well, that gives me 36. So I see that they're not a common difference. So it's not going to end up being that. So what I'm going to look for is a common ratio of y to x. And so when I look at those, I do 20 over 2, and that makes 10. And I try another one, and that would be 40 over 2, or 40 over 4, that makes 10 as well. So I see there is a common ratio. So that common ratio is 10. So that means you're going to multiply the x value by this number. So it's going to look like this. Y is going to equal, and that's the output y, is going to equal 10 times x. And it works because you see 9 times 10 makes 90, 8 times 10 makes 80, 4 times 10 makes 40, and so on. So the part that's missing right here would just be a 10x, and that's what we're looking for there. So same sort of thing on this next one. Again, you look for common differences, but you could probably do those in your head. 2 minus, actually let's start with the y first. So let's write down 2 minus, or 1 minus 2. 1 minus 2. So I'm starting with the y's and taking the difference, and I see I get negative 1. And then when I look at the next one, 2 minus 4, I don't get the same number. So I know it's not that common difference. It's not that one. So I need to look at the common ratio. And so I go y to x. So that way I know what I'm multiplying by. And when I do that, the first one I set up is 1/2. Well, the next one's 2 over 4, but that reduces down to 1/2. So that means the common ratio is going to end up being that 1/2. So what we're going to do is we're going to take the x value and we're going to multiply it by 1/2. Just like here, the common ratio was 10, so I multiplied by 10. So that means the amount of minutes or amount of miles is going to end up being 1/2 x if x is the number of minutes. So that would be our answer. Well, the next problem asks us to draw a picture to represent the situation. And it says that Ed drives to school in the morning and stays for 4 hours. So we're going to go up, and he stays there for 4 hours, so we'll go over. And then before driving to work, which is half the way between school and home. So we go down at an angle, but not all the way home. And then he stays there at work for 5 hours. And so that continues on, and then eventually he ends up going home. So that line should be straight that I'm trying to draw right there, and then he ends up going home. So the next one, it talks about how Ned starts riding his bike and accelerates to a constant rate. So we know that he starts riding his bike and accelerates. That means it's going up, and then he maintains this constant rate for a while. He slows down to a stop, so we go down all the way to where it stops, and then he resumes biking, but at a slower pace. So he must, it doesn't say how long he stopped for, so we'll just continue on from that point there. But then he goes at a slower pace, which would end up being not as high as the first one. So those are the types of problems you'll see from 215. Check the next part for the last few problems.